Good morning, dear students. Let's start your lesson 1 in unit 2. Let's see this video.
Electricity is the movement of charged atomic particles called electrons. Moving electrons create the drama and power of a lightning strike. They also light up your room when you flip the switch. A battery is a chemical device designed to create the force needed to move electrons. Conductors, usually metals like copper, provide a path for the electrons to flow on. Electrons have a negative charge. They travel out of the minus end of the battery and are attracted to the plus end. Touch a metal conductor to each end of a battery and electrons begin to flow from minus to plus. Flowing electrons are called current. Current is measured in amperes. The force moving the electrons is voltage and is measured in volts. Never connect a short wire from the minus to plus on any battery. This is called a short circuit. The conductor gets hot, you might burn yourself, and the battery quickly loses energy. The path that an electric current follows is called a circuit. This circuit has a light bulb in it. To move electricity through the bulb, we complete the circuit by touching the metal wire to each end of the battery. The wire does not get hot because the light bulb reduces the current flowing in this circuit. Electric energy changes to light energy. Slowing things down, we can see that once the circuit is complete, an electric current appears, flowing from the minus end of the battery toward the plus end.
Okay, so today's lesson is about electricity or electric lamps. Electric lamps. So this is the first lesson in unit 2. We know all that the sun is the main source of light on Earth. It gives us light and energy. But when it's night, how can we get light? We get an artificial light by electricity. So we are going to see the electric lamps. The electric lamps are tools that convert electric energy by passing electric current through them. So these are tools that convert the electric energy that comes from electricity by passing electric current through them. But what is the meaning of electric current? We have seen now in the movie, it is a flow of electric charges, which are called electrons, small, very small particles, through a material conducting electricity. What is electric current? An electric current is a flow of electric charges through a material conducting electricity. So today's lesson is electric lamps. We have two types of electric lamps. We're going to study two types only of electric lamps. The light bulbs and the fluorescent lamps. The light bulbs and the fluorescent lamps. Let's see one by one. First, the light bulb. Where did you see ever the light bulb? It is used in lighting houses. Our houses use the light bulb, the car lights, and the torches. So the uses of the light bulb is lighting houses, car lights, or torches. What we have here is the structure of the light bulb. So the light bulb is composed of, first, from outside, the glass bulb. The glass bulb, it's made of glass. A base of the light bulb, a piece of lead, which is connected to the electricity or to the current, two copper and lead wires, which are connected to what we call a tungsten filament. You see this thin filament here? It's called tungsten filament. The glass bulb is filled with argon gas, which is an inert gas. We are going to see why do we use an inert gas. So once more, the parts of the light bulb are the glass bulb, the base of the light bulb, a piece of lead, copper and lead wires, tungsten filament, and the glass bulb is filled with argon gas. Let's see each part in details. Let's start by the filament. This is the filament. It is a coiled thin wire made of tungsten. It is made of tungsten. Why do we use tungsten? Because it has a high melting point. Because the light bulb works when the tungsten filament is heated to a high point. So that's why we use a filament made of tungsten. So because it has a high melting point, so it will not be damaged by high temperatures. The filament is connected to two copper and lead wires. Can you see them clearly here? These are the two copper and lead wires which are connected to the base of the bulb. So how do the light bulb works? Electricity reaches the filament, the tungsten filament, through the base, which conducts electricity to the copper and lead wires, and then reaches the filament, the tungsten filament, that has a high melting point. So it heats up and emits light. That's how the light bulb works. What is the function of the filament? The filament heats up and emits light when the electric current passes through it. The tungsten filament heats up and emits light when the electric current passes through the filament. What is the function of the lead and copper wires? The lead and copper wires. What is the function of this lead and copper wires? They let electricity pass through them from the base. They allow electricity to pass through them from the base. We said the base is connected to electricity. So they let electricity, or they allow electricity to pass through them from the base to the tungsten filament. Right? Now, what about the glass bulb? What about the glass bulb? It is made of thin glass. It is made of thin glass, and it is filled with argon gas. Remember, we said it is filled with argon gas, which is an inactive gas. Why do you think we use an inactive gas? So the glass bulb works as an insulator. You know what is the meaning of insulator? It isolates the filament from air. Now, who knows why does it isolate the filament from air? You remember we took gases in the first term. We said that the atmosphere or air is composed of carbon dioxide, oxygen, nitrogen, and water vapor. And we remember that we said oxygen helps in burning. So to isolate the filament from oxygen, we use a thin glass, which is filled with argon gas. And argon gas is an inactive gas, so it protects the filament from burning. It protects the filament from burning. Now, if you have the question, give reason, argon gas increases the lifetime of the filament. How do argon gas increases the lifetime of the filament? Because it is an inactive gas, so it protects the filament. It doesn't react with it, so it protects the filament. The base of the light bulb. What is the function of the base of the light bulb? It has two functions. First one, it carries the light bulb in upright position. It carries the light bulb in upright position. Function number two, it connects the light bulb to electricity. It connects the light bulb to electricity. And we have two types of base of the light bulb. I'm sure you have already seen these two kinds or two types, a spiral base and side nails. This is a spiral base and two side nails. Now, what about the fluorescent lamps? The fluorescent lamps are known as neon lamps. I'm sure you have already seen fluorescent lamps in lighting houses and shops, decorating commercials, and advertisements. What is the structure of fluorescent lamp? Let's see the fluorescent lamp. This is the fluorescent lamp. So this is the light bulb. This is the fluorescent lamp. The fluorescent lamp is composed of three main parts: the glass tube, filaments, and the points of connection. The glass tube, filaments, and points of connection. The glass tube is vacuumed and filled with argon gas and a little of mercury. Remember we said mercury vapor. Mercury vapor. So it is vacuumed and filled with argon gas and a little of mercury. The inner surface is covered with a phosphoric material. The inner surface is covered with a phosphoric material. So the structure of the fluorescent lamp is formed of glass tube, filaments, and points of connection. The filaments are at the tips of the lamp from the inside. The filaments are at the tips of the lamps from inside. This is a filament. Okay, this is a filament. So they are found at the tips of the lamp from inside. The points of connection. We have two points of connection on each tip. So this is the first tip and there another tip. So there are 2 points of connection on each tip of the lamp to connect the fluorescent lamp to electricity. Right? So these are the 3 main parts of the fluorescent lamp.